Hello, welcome to all. Today is our lecture on finding the ABCD parameter of medium transmission line and long transmission line. In a previous lecture, we studied about to find the ABCD parameter of short transmission line and medium transmission line with T method. Now here we see that a equivalent circuit of medium transmission line is here. There is a pi network we see in the figure. In a pi method, we use capacitance as at half as receiving end and half as sending end. And here is our impedance. The sending end voltage, which is Vs, sending end current, which is Is, receiving end current, which is Ir, and receiving end voltage, which is Vr. When sending end current flow, it divides into current, a line current IL and second capacitor current IC2. When line current are flow at receiving end, it divides in two parts, receiving end current IR and capacitor 1 current IC1. So here we want to find a sending end voltage and sending end current equation based on receiving end voltage and receiving end current. So first of all, we have to find now sending end current. We see that Is, which is equal to IC2 plus IL plus IC2. Now current IL, which is equal to IC1 plus IR. So IL, which is equal to IC1 plus IR. Now current IC2 are flowing in the capacitance Y by 2 or admittance Y by 2. So the value of the current IC2, which is equal to Y by 2 into Vs. Now capacitor current IC1 are flowing in the admittance at receiving end. So voltage is Vr and IC1, which is equal to Jy by 2 into Vr. Now we have both the value for the capacitor current IC2 and IC1. Now we put the value of IC2 in our sending end current equation. We get Is, which is equal to IL plus Jy by 2 Vs. Now in line current IL, which is equal to Jy by 2 Vr plus IR. So here is the value for sending end current and line current IL. Now here we see the sending end voltage equation Vs. Sending end voltage Vs, which is equal to our impedance drop plus our receiving end voltage, because the capacitor voltage, which is parallel to receiving end voltage Vr load. So first capacitor voltage is Vr. So here Vs, which is equal to a impedance drop, and impedance drop due to current IL. So IL into Z plus Vr. So here is the sending end voltage equation. Now we put the value of IL current in the Vs equation. So Vs which is equal to, now IL which is equal to Jy by 2 VR plus IR into Z plus VR. So now we multiply Z in the equation, we get Vs J Z y by 2 VR plus Z IR plus VR. Now take common value of VR, we get VR 1 plus J Zy by 2 plus Z into IR. So now here we see that the equation is sending in voltage form, and also we have a VR and IR value, and another are the constant value. So here is the sending end voltage equation for our ABCD parameter, equation number 1. Now we find the value for the sending end current. So we find the voltage equation. First we write Vs V is equal to VR plus 1 Zy by 2 plus ZIR. So now we find a current equation, sending in current equation Is, and Is which is equal to IL plus IC2, and which is equal to IL plus Y by 2 Vs. Now IL which is equal to IC1 plus IR, and IC1 which is equal to Y by 2 VR plus IR. So all this equation we derived above, we just rewrite this equation only for our use. So first we find the sending end current. So here Is which is equal to IL plus Y by 2 Vs. Now we put the value of IL in this equation, which is equal to Y by 2 VR plus IR plus Y by 2 Vs. So here we see that equation is sending in current there, VR and IR there, but also a sending in voltage is also here. So we eliminate this equation, we put the value of Vs in this equation. So Y by 2 VR plus IR plus Y by 2. Now Vs which is equal to VR 1 plus Zy by 2 plus ZIR. Now we first multiply with the VR. So Y by 2 VR plus IR plus Y by 2 VR plus Zy by 2 VR plus ZIR. Now we multiply this equation with Y by 2. We get Y by 2 VR plus IR plus Y by 2 VR plus ZY square by 4 VR plus ZY by 2 IR. Now here we see that there is a receiving end voltage and receiving end current are there. We common the value of receiving end voltage first. So VR we take common. So here is a Y by 2 plus here is a Y by 2 plus ZY square by 4. Now take common value of IR. So IR take common, we get 1 plus ZY by 2. Now VR as it is a Y by 2 plus Y by 2 which is Y plus ZY square by 4 plus IR 1 plus ZY by 2. So this is the equation for sending end current. Now first equation for sending end voltage and now second equation for sending end current. Now we compare this equation number 1 and equation number 2 with our generalized parameter equation. So here is the both equation for sending end voltage and sending end current, and here is the generalized equation for sending end voltage and sending end current. Now compare these two equation. First, sending end voltage, Vs which is equal to Vr 1 plus Zy by 2. Here Vr into A, so A is equal to 1 plus Zy by 2. Now B into IR, so B is equal to Z. Now VR into C, here VR into Y plus ZY square by 4. So C is equal to Y plus ZY square by 4. Now IR into D, here 1 plus ZY by 2. So D is equal to 1 plus ZY by 2. Now this A, B, C, D, which are our parameters. So we apply the condition. First one is A is equal to D. So A is equal to 1 plus ZY by 2 and D is equal to 1 plus ZY by 2. So both are equal. Now AD minus BC, which is equal to 1. So for that purpose we write AD minus BC. A is equal to 1 plus ZY by 2. D is equal to 1 plus ZY by 2 minus B is equal to Z and C is equal to Y plus ZY square by 4. Now multiply this equation, we get 1 plus ZY square by ZY by 2 whole raised to square minus ZY plus ZY square by 4. Sorry, Z square Y square by 4. So here ZY by 4 whole raised to ZY by 2 whole raised to square. So we solute this 1 plus 2 into ZY by 2 plus Z square Y square by 4 minus ZY minus Z square Y square by 4. So 2 to eliminate, so ZY is here minus ZY. Now Z square Y square by 4 minus Z square Y square by 4, this eliminate, so is equal to 1. So here we our parameters, which is A, B, C, D, is here. Now from this parameter we find out the value of ABCD and then we find out the value of sending end voltage and sending end current. Now we see how the ABCD parameters we find for the long transmission line. Now long transmission line with rigorous method. We already find the sending end voltage and sending end current equation with the help of rigorous method for a long transmission line, which is Vs which is equal to Vr cos h under root yz plus Ir under root z by y sin h under root yz, and sending end current equation, which is Vr under root yz y by z sin h under root yz plus Ir cos h under root yz. Now already this equation are in Vr and Ir form for sending end voltage and sending end current. So we directly compare this equation with our generalized equation so that from the generalized equation here we see that here is AVR and here is VR cos h under root yz. So A is equal to cos h under root yz. Now BIR, so here B is equal to under root z by y sin h under root yz. Now from the sending and current equation, VRC, here VR under root YZ, Y by Z sin H under root YZ. So C is equal to under root Y by Z sin H under root YZ. Now D is equal to cos H under root YZ. So these are the ABCD parameters for the long transmission line. Now we apply the condition for A is equal to D. Here we see that A is equal to cos H under root YZ and D is equal to cos H under root YZ. Both are equal. Now AD minus BC is equal to 1 we apply. A, which is equal to cos H under root YZ, into D is equal to cos H under root YZ minus B, which is equal to under root Z by Y sin H under root YZ, into C is equal to under root Y by Z sin H under root YZ. Now cos H under root YZ into cos H under root YZ, which is cos H square under root YZ minus Z by Y and Y by Z are eliminated. So sin H under root YZ into sin H under root YZ, which is sin H square under root YZ. So for the hyperbolic form, we know that cos H square minus sin H square, which is equal to 1. So cos H square under root YZ minus sin H square under root YZ, which is equal to 1. So the condition, second condition also proved. So these are the ABCD parameter for the long transmission line. Now we see the example with the help of ABCD parameter. Here we see the example. Find the following for the single circuit transmission line delivering a load of 50 MVA at 110 kilowatt and power factor 0.8 lagging. Find out the sending end voltage, sending end current, sending end power, efficiency of transmission, and also given A is equal to D, which is equal to 0.98 angle 3, B is equal to 110.75 ohms, and C is equal to 0.005 under root 80 Siemens. So here we see that A is equal to D and are dimensionless, and B and C, which are ohms and Siemens respectively. Now we find out the sending end voltage and sending end current. First of all, in given data we have given the value power P given, which is 50 MVA, a voltage given VR, which is 110 kilowatt, and also value of A and D, which is 0.98 angle 3, B is equal to 110 angle 75, C is equal to 0.0005 angle 80 degree, and also power factor given cos phi r, which is 0.8. Now from the power factor we find the angle phi r and then find sin phi r, which is 0.6. So here is the given data. Now we have to find a sending end voltage and sending end current. So for that we have a two equation for the sending end voltage and sending end current. Vs, which is equal to Vr into A plus IR into B, and Is is equal to VR into C plus IR into C. Now using this equation we find the value of sending end voltage and sending end current, then sending end power and efficiency. So first we find a sending end voltage. Now here we see that a voltage VR, which is given in our data, which is 110 kilowatt, we divide by root 3 and we get the phase value. So 110 divided by root 3, we get 63.5 kilowatt phase value for VR. Now find out receiving end current, and receiving end current we have an equation P is equal to VI. So from this equation we find the value of current IR, which is equal to P upon V into 10 raised to 3. P is equal to 50 megawatt given in our data, and voltage is given 110. So 50 into 10 raised to 6 divided by 110 into 10 raised to 3, we get the value 262.4 ampere IR. So now VR and IR we find. Now we know that we taken VR as a reference value. So VR, which is equal to 65,000 plus J0, because angle we take 0. Now vector value of current IR. So IR is equal to IR cos phi R minus J sin phi R. Already this type of equation we derive in T method and pi method. So we know that. So we put the value of cos phi R and sin phi R. We already find cos phi R and sin phi R, which is 0.8 and 0.6, and IR, which is 262.4 ampere. So put all the value and we get IR, which is equal to 210 minus J 157.5 ampere. Now sending end voltage per phase. A sending end voltage per phase for a generalized equation, which is Vs is equal to AVR plus BIR. So first we find AVR and then BIR, then find sending end voltage. So first AVR. So value of A given in our data, which is 0.98 angle 3, and VR, which is 110 kilowatt, and we get 63.5 phase value. So here we put this value AVR 0.93 angle 3 into 63,500 voltage, and we get 62,230 angle 3. Now multiplication and division of angle we described in long transmission line. So if you not understand how this multiplication and division of angle are done, you just revise this lecture. Now BVR, value of B is given in our data, which is 110 and angle 75. We multiply with the current IR, and IR value, which is 210 minus J 157.5. So we get the value of BVR, which is 22,702 plus J 17,826 ampere. Now Vs. So find out Vs, which is equal to AVR plus BVR. So we take sum of AVR plus BVR, and we get value of Vs 87,427 with angle 14. Now magnitude of sending end voltage, which is 87,427. Now we find the sending end current. Now here is the sending end current equation, IS CVR DIR. So first we find CVR value. Value of C is given in our data, which is 0.05 angle 80, and VR value 63,500 with angle 0. So we get 5.5 plus J 31.3. Now DIR. For DIR, value of D is given in data, which is 0.98 angle 3 into value of IR, and we get DIR is equal to 213.5 minus J 140.3 ampere. Now sum of this CVR and DVR, we get a sending end current IS, so which is equal to 5.5 plus J 13.1 plus 213.5 minus J 943.3, and we get IS is equal to 246 angle minus 27 ampere. 246 is the magnitude of sending end current. Now for find out the sending end power. Sending end power, which is 3 Vs Is cos phi s. So 3 into Vs, which is 87,427, into Is, which is 246, and for cos phi s, finding out the angle, power factor angle phi s, we have an angle for sending end voltage and sending end current. So we 27 minus 14, we get cos phi s. So the final sending end power, which is 48.6 megawatt. Now receiving end power. So the value of receiving end power is given in data, which is 50. Now multiply with the power factor, we get the megawatt value for receiving end power, which is 40 megawatt. Now find out the efficiency, which is the receiving end power upon sending end power. So receiving end power 40 megawatt divided by 48.6 sending end power, and we get 82.3% efficiency. Now the next lecture we discuss about the power flow equation of transmission line. Thank you.